All right, we're moving into IA-15 Part 2. This was the second objective of this lesson. And we start out with the rules for this objective, which has to do with solving equations that involve rational expressions. You've probably done this before, but the denominators may have all been real numbers. Some of our problems now will have denominators which have variables in them. When that's the case, we're going to have to be very careful to check domain exclusions. And you check domain exclusions at the beginning of the problem. Write it down and then check and see if you violated it toward the end of the problem. All right. Although the typical rule for solving equations that involve rational expressions is to find the LCD and multiply both sides by it, number 8 is a special kind of problem. It is a proportion. And a proportion is a fraction equal to another fraction. And when you have this cross product is equal to this cross product. So you could make the statement that A times D is equal to B times C. We're going to do that. We are going to be watchful of domain exclusions, but let's see. This denominator is just a number. This one is just a number. So there are no domain exclusions. So I'm going to take v minus 9 over 2 equals v over 5, and I'm going to look at the cross products. 5 times v minus 9, and I'm going to use my parentheses, will equal 2 times v. This is a linear equation to solve. Quadratic equations have an x squared. These do not. 5 times v is 5v. 5 times negative 9 is negative 45 equals 2v. I choose to subtract 5v from both sides. That leaves me with negative 45 is equal to positive 2, and negative 5 is negative 3v. Divide by negative 3. 15 is equal to v. There were no domain exclusions to worry about. The answer to this is 15. Now the next problem is not a proportion. Since it's not a proportion, I have to use the very traditional step, find the LCD, multiply both sides by it, reduce each product, no fractions will remain, solve it, check the domain. So here we go. When I write this down, I'm going to leave some spaces. I'll show you why. I have w minus 6 over 6 plus, leave a little space, w minus 5 over 7 equal sign, leave a little space, 7 over 6. The LCD of all of these denominators, I have a 6, a 7, and a 6, so the LCD is 42, which is the product of those. I'm going to, in red, multiply the left side by 42, and I do that by multiplying each term by 42, and then the right side by 42. That's actually the multiplication property of equality that says I can do that. I will look at this product, this product, this product. All right, in the first product, 6 goes in there once, 6 goes in there 7 times, and I have 7 parentheses w minus 6. Bring down my plus sign. 7 goes into 42 6 times, and I have 6 parentheses w minus 5. Close parentheses, equal sign. 6 goes in there once, 6 goes in there 7 times. I have 7 times 7, which is 49. This again is a linear equation, not quadratic, so I will just solve it the way I have for years. 7 times w is 7w. 7 times negative 6 is negative 42, plus 6 times w is 6w. 6 times negative 5 is negative 30, equal sign 49. I have 7w and 6w. For 13w, I'm combining like terms. I have minus 42 and minus 30 for minus 72 is equal to 49. Now I'm going to add 72 to both sides. I end with 13w is equal to 121. Divide by 13. 13 does not go into 121 evenly, nor does it reduce, so my value for w is 121 over 13. In this problem, there were no domain exclusions because the denominators were all numbers, no variables. Let's look at number 10. Now, something that's different about number 10 is that the denominators contain variables. So there can be a domain exclusion. So I'm going to go ahead and look at that. Both of the variable expressions are y minus 8. So if I set that equal to 0, y is equal to 8. That is the domain exclusion. I don't have to list it, but I have to be careful because as I solve the problem, if I happen to get an answer y equals 8, I would have to throw it away because it violates the domain of the original problem. The least common denominator is the only denominator. It is y minus 8. So I'm going to have 9y over y minus 8 plus, leave a space, 2, equal sign, leave a space, 3y over y minus 8. Switching to red, I'm going to multiply by the LCD, which is y minus 8, y minus 8, y minus 8. In the first product, for the first term, the y minus 8's divide out, and I get 9y plus, well, there's nothing to divide out here. So I've just got, I'm going to move the 2 in front, 2 times y minus 8 equals, all I did was switch the order. These divide out, and I'm left with 3y. So I simplified each one of those. This is a linear equation. I'll keep the 9y, distributive property, plus 2y. 2 times negative 8 is negative 16 equals 3y. And, sorry, had to make that go away. Simplifying, 9y and 2y makes 11y minus 16 equals 3y. I have y's on both sides. I'm going to subtract 11y, and I have negative 16 is equal to negative 8y. Divide both sides by negative 8, and I get 2 is equal to y. And I want to pause because I think that's my answer. Does that violate the domain? No, the only exclusion was 8, and I got 2, so I'm okay. You have to be careful because when you get an answer to a rational equation, you're getting an answer to the version of the equation that does not have fractions. You have to double check that this answer in no way violates the domain of the original. And the only number that would have been a problem would have been 8, which is what I determined at the beginning. Let's go to number 11. All right, I am going to have to worry about domain exclusions. I know that a minus 8 equals 0 causes me trouble. So if a is 8, it should be excluded from the domain. The LCD here is a minus 8 because it's the only denominator. So I have the equation 6 plus, leave a space, 40 over a minus 8 equals sign, leave a space, 5a over a minus 8. I'm going to multiply by that LCD in red. So I'm going to multiply a minus 8 times the 6 and a minus 8 times that fraction and a minus 8 times that fraction. And I will need to look at each one of those. Here I'm going to use the distributive property. That's going to be 6a minus 48 because I multiplied by 6 plus those divide out and I have 40 equals those divide out and I get 5a. This is a linear equation, so I will simplify it, keeping the 6a, negative 48, positive 40 gives me negative 8 equals 5a. Now I have a's on both sides. It's up to you. I choose to subtract 6a. That leaves my constant alone, and I get negative implied 1a. Divide by negative 1. Divide by negative 1. 8 is equal to a. And that is the answer to this equation. But this time, do you see domain exclusion is the answer? This answer won't check because if I plugged it in up here, it would cause this denominator and this denominator to be 0, therefore undefined expressions. This won't work. I have no solution. It is easy to overlook that checking. You must check to see if your answer violates the domain. Number 12. This is the first problem I've had where I have a fraction. The second fraction, I can factor that denominator. And that's the difference of squares, so I can factor that into, had an A on my head, x plus 3 times x minus 3. All right, that does a few things for me. The domain exclusions, those are any time a factor of a denominator becomes 0. So if x plus 3 is 0, x is negative 3. That comes from here. It comes again from here. I also have x minus 3 equals 0, which means x is 3. I have two domain exclusions, and I will just keep that in the back of my mind. I need the least common denominator. I need one of every different kind of factor, which means I need an x plus 3 and I need an x minus 3. Don't put the x plus 3 in there twice. You just need one of every different kind. So, writing down my problem, I have 1 over x plus 3 plus space 6 over, and I'm going to write this in factored form, x plus 3 times x minus 3 equal sign space number 1. I think I'm going to give myself some more room, and I'm going to get my red pen for multiplying by the least common denominator, which is x plus 3 times x minus 3, x plus 3 times x minus 3, x plus 3 times x minus 3. I need to do this, this, and this. In the first product, the x plus 3's divide out, and I'm left with x minus 3 times 1, which is x minus 3. Plus sign. In the second group, the x plus 3's divide out, the x minus 3's divide out, and I'm left with 6. Equal sign. I need to multiply these times 1. 1's the identity, so I just multiply these, and I get x squared minus 9, because that's a sum and difference product. Because of this x squared, this is a quadratic equation. That means that I need to get x squared with all the other terms on one side and 0 on the opposite side. I will go ahead and combine these two. So I have x, negative 3 and positive 6 gives me plus 3 is equal to x squared minus 9. Subtract x, subtract x, subtract 3, and I get 0 on the left is equal to x squared from here minus x from here, and then negative 9 and negative 3 gives me negative 12. This is a quadratic equation. In quadratic equations, the only technique we have for solving them right now is factoring. So it's 0 is equal to x minus 4 times x plus 3. If x minus 4 is the factor making this be 0, x is 4. If x plus 3 is the factor making this 0, x is negative 3. And are either one of these domain exclusions? So I go back up. Oh, look there. Negative 3 is. That means this cannot be a solution. My only answer is x is 4. So if you look at this, when I solved the problem, I got two solutions, but one of the solutions violated the domain. It was a domain exclusion, so I had to remove it. The only other answer was 4. Let's look at number 13. Oh, it's been a few problems, but we have a proportion. I will go ahead and mention that the domain, if t minus 9 is 0, t is 9, and that's my domain exclusion. All right, so I have t over t minus 9 is equal to t plus 9 over 24. Because this is a proportion, the cross products are equal. 24 times t is 24t, equal sign. The right hand side is t minus 9 times t plus 9. So I keep 24t is equal to, this is a sum and difference product, and it becomes t squared minus 81 when you multiply, perhaps by using FOIL. Subtract 24t from both sides because you want a 0 when it's quadratic, and this is quadratic. 0 is equal to t squared minus 24t minus 81. 0 is equal to, I know I need 1 plus and 1 minus, put in the t's. Now for 81, it's 1 times 81, 2 doesn't go in there, but 3 goes in there 27 times, and 9 goes in there 9 times. I need a difference of 24. It's going to be here. And I need the 3 to be plus, and then the 27 to be minus, so that I get a middle term that's negative. That means that t could be negative 3, or t could be 27. Are either one of those violation domains of the domain? No. 9 is the only exclusion. So I have two answers. I have negative 3 and positive 27, and it does not matter about the order that you enter them. All right, I think we're on our last problem now. This is not a proportion. It does have a denominator that could be factored. I will need to factor it. Looks like trial and error. 1 plus, 1 minus. I need an R and an R. I need factors of 24 with a difference of 2. So how about 6 and 4? For domain exclusions, I know that if r plus 6 is 0, r would be negative 6. That would need to be excluded. If r minus 4 is 0, r equals 4 would need to be excluded. This is a repeat of getting the minus 6. This is a repeat of getting the positive 4. So I will keep those in mind to check at the end of my problem. But I need a least common denominator also. I now have everything in factored form, and I need an r plus 6 and an r minus 4 because I simply need one of every different kind of factor. So I have 3r minus 3 over, in factored form, r plus 6 times r minus 4 plus space 3 over r plus 6 equals space 3 over r minus 4. I've put those binomials in parentheses. That's optional. I'm going to go to the, whoops, I don't know why that opened. Let's see, give me just a minute. All right, not sure what I touched, but I am going to now multiply by this LCD. So I need an r plus 6 times an r minus 4 and an r plus 6 times an r minus 4 and an r plus 6 times an r minus 4. Back to black ink. I need to look at this, and look at this. For the first one, the r plus 6 and the r minus 4 both cancel out, and I have 3r minus 3 plus sign. The r plus 6 divides out, and I have 3 times r minus 4 equal sign. The r minus 4 divides out, and I have 3 times r plus 6. Using the distributive property to simplify, I have 3r minus 3 plus 3r minus 12 equals 3r plus 18. Simplifying like terms, I have 6r minus 15 equals 3r plus 18. I'm going to get the r's on one side by subtracting 3r from both sides. That gives me 3r minus 15, because 6 minus 3 gave me 3, equals 18. Add 15 to both sides. I have 3r is equal to 33. Divide by 3. And it looks like r is 11. Take a glance. 11 was not a domain exclusion, so it is the solution. All right, this was the second video on this lesson. It concluded our study of rational expressions.